Hey everybody, I want to walk through the process of drawing a bicycle in a CAD program. This program is Rhino. I'm going to be working on the full suspension bike that I plan to build as the Build It, Ride It project bike. Build It, Ride It project bike. And so this is going to be a single pivot suspension bike, and it's going to have 27.5-inch wheels. Got some of the features kind of laid out here. And so, this is really the starting point for me anyways, is trying to figure out, what those specs are. So it gives me something to work with. And so, for the sake of this bike, front wheel diameter, that's the bead seat diameter. It's associated with 27.5-inch wheels, 584 millimeters. All these dimensions are either in millimeters or degrees. Front tire diameter, this is just kind of a guesstimate. It's a 27.5 by 3-inch tire that I'll be running on the front. It's about 725 millimeters in diameter. Front travel on a fork, it's a 2019 RockShox Pike 130. It's a 29er, for 27.5 plus, right? So that 3-inch tire that is run on the front kind of requires you running the 29er fork. Axle to crown, this actually comes right from SRAM's specs. They have them on their website. So if you're looking for this information, I haven't seen anything terribly updated, but if we go to SRAM's website, and if you scroll down to the bottom, which is manuals, documents, and videos, and they have, for 2019, luckily for me, right, these technical specs. I was looking through some of this other stuff, and I didn't see anything equivalent to this to show the axle to crown. They used to have the axle to crown specs actually in the literature on the web page for a particular fork, and maybe they do now again, but they took it off for a while. So anyway, if we go in here and we open this up, you want to go down to technical specifications, zoom in a little bit. If we find the Pike, these are the 29, and then I've got a 51 offset. So 130 travel, come across, the axle to crown is 541. So that is how I got to this number. Sag, what we're going to be running in sag is basically the percentage of the travel that when you sit on the bike, that the fork compresses that much, right? So the travel is 130, 20% of 130 is 26 millimeters. And so that means that sag axle to crown is 515 millimeters. And then, like I mentioned before, the rake or the offset, it's 51 millimeters. So, all that to say, that's really the starting point. We need to know our axle to crown and our rake as we start to go down the path of actually drawing the bike. So first thing we do, or at least first thing I do, I just draw a vertical line and I offset it 51 millimeters. And then I connect these two things. Zoom out a little bit. I'm going to put a point here, and that's really the front of the front wheel, or sorry, the center of the front wheel. And I'm going to draw a circle, and this circle is going to have the diameter of the axle to crown compressed. So 515, if I remember right. It's going to have the radius of 515. Sorry if I said diameter before, radius of 515. And then we're going to extend to here. This line, right? So then when we draw a line from here to here, it's going to be on the circle. And so we know that's 515 millimeters, right? If we want to be sure, we can measure it. 515. And just to go back to that initial spreadsheet, 515 sag axle to crown. Again, we got that by taking the full axle to crown on the specs, subtracting the sag, and getting that axle to crown. The next number we need is the head tube angle. So the head tube angle is 66 degrees. So that line that we drew that's vertical is now going to tilt back 66 degrees to 66 degrees. So we're going to rotate this with this as the center point, that front axle, and it's going to be rotated 90 degrees minus 66 degrees. So we're going to do 24 degrees, right? And we'll put a point there, and that'll be the base of the head tube, and also that lower headset cup really is what we're looking at there. So the next thing we want to do is offset this by the amount that the head tube diameter. The head tube diameter in this case, where I'm using a Paragon Machine Works 1.5-inch head tube, and so it is 47.6 millimeters in diameter, and then we're going to divide that by 2. So 47.6 divided by 2. Zoom in, and so I just offsetted that center line by the radius of the head tube, and draw a line from here to here. And because I offset it, it automatically goes through that point. So we can actually, I'll keep those. So the next thing I want to do is offset the bottom point here, or the bottom line that runs through this point, by that headset cup depth. And headset cups are 1/2 inch, so 12.7 millimeters. Okay, so I just extended these 2 lines up here, and this is really represents that the lower headset cup. So if I trim these now, I have that lower headset cup all set up. The next thing I want to do, delete this line, is figure out what my where the top of that head tube needs to be. We go back here, front wheel bottom bracket drop. I want it to be 58 millimeters. There's a slight difference between the front wheel and the rear wheel. I'm going to run a 3-inch tire on the front and a 2.6 in the back. So 725 front wheel diameter, and the rear wheel diameter is 715. So really what I'm trying to do is hit roughly 55 millimeters on average. And so if we take the difference in the radius of these tires, it's 5 millimeters, and so 58 minus 5, which will be the rear bottom bracket drop, the average of those is roughly 55. It's 55 and a half. So I'm going to use that 58 number. The other number I need is a stack. So how high above that bottom bracket does the top of the head tube sit? And so 58 and 625 are those next 2 numbers that I need. So to get the drop, I'm going to offset this line, which is the axle, 58 millimeters downward. And so the bottom bracket is going to lie somewhere on that line. And then I'm going to offset this up 625 to figure out where the top of the head tube needs to be. And we extend this line up to the top. Here we see that the distance of the head tube is going to be roughly 118 millimeters. And so head tubes come in size increments of 5 millimeters. They're not cut to size, or at least the ones that I'm using. And so I could either go bigger, go to up to 120, and have a little bit more real estate on the head tube to weld the top tube and the down tube to. But I actually want a little bit more real estate in the stack. I'm actually gonna, my son is gonna be riding with me on this bike. He's 3, and so we have one of those Mac rides, and I need a little bit of extra room with those the spacers, the headset spacers, so that I can install the Mac ride. So I'm going to use a 115 millimeter head tube. So I'm going to offset this line here 115 millimeters, and then I'm going to put a point right here, and I'm going to draw two lines that represent the sides of the head tube, one here, one here. So I didn't quite get to my desired stack height, but it'll be fine. Yeah, that stack is just kind of a reference. My hands will end up being where I want them to be when I actually have everything where it needs to be. So I'm going to trim this line just to clean things up. The stack height line, I'm going to make that go away. And then the next thing we need to do, we need to figure out where that bottom bracket is going to sit. So I'm going to draw a vertical line from the top of that head tube. And then I am going to go back to my reference sheet here and say, okay, what's the reach? And so the reach is the distance from the center line of your head tube back to the center line of your bottom bracket shell. And so go back there one more time, 450 millimeter reach. So what we'll do is offset this line 450 millimeters this way. And of course, these numbers are all for me. Depending on who you're building your bike frame for, you're going to have different numbers. You can get these numbers. The best way to get these numbers, if you're working on your first frame, is to go to the website, where the bike, for a bike that you have, that that you like the geometry, and figure out what that stack and reach are. Those are the numbers nowadays. It used to be that there was a top tube, horizontal top tube distance was really the replacement for reach. So you can use that number, kind of a different process of arriving at the drawing in that sense. Instead, we'd be offsetting this line back, that horizontal top tube difference at distance, and then kind of figuring out how the seat tube interacted with that to get down to the bottom bracket. This way is actually a lot easier, with reach and stack, because you find where everything is, really simply. So the next thing I'm going to do, I'm going to just keep doing this in the background, but I'm going to draw a point where the bottom bracket shell is going to be, and then I'm going to draw a circle. Bottom bracket shells, at least the BSA or English threaded bottom bracket shells, again, Paragon Machine Works. They're 38.1 millimeters in diameter, which is 1.5 inches. So 38.1. And now we have the beginnings of a bike. We've got our head tube, we've got our bottom bracket shell. And the next number that I'm going to grab here is the bottom bracket to saddle distance. And so this is really a key measurement as well, and you can pull it from your favorite bike, but when your saddle's in the fully extended position, if you have a dropper post, measure from the center line of your bottom bracket shell to the top of your saddle, and that's really the distance you need to have for efficient pedaling. And this is the baseline of where the saddle is going to be. I guess dropping back a little bit, I'm drawing this bike in sag, and a lot of times you'll see bikes, the geometries listed, I think most all the time, you'll see bike geometries listed not sagged. And so, these numbers will be a little different. And even, hardtails, they'll list them, full extension. I like drawing my bike sag because I know where everything's going to be when I'm actually riding it. All right, so circle from here, radius of 730, right? And then the other number we need is the seat tube angle. We're going to run a 74.5 degree seat tube angle. So we're going to rotate this line at the center point of the bottom bracket shell, and we're going to rotate it 90 minus 74.5, so 15.5. Hopefully that's right. We can double check. 74.5, right? If we want to, should have done this before, but if we want to double check this one, 66, right? We'll come back and dimension this whole thing later, but for right now, I'm going to leave the dimensions off to keep it clean. And then I'm going to put a point at that saddle area. Okay. We've got a lot of good stuff going on here. Got the very basic formations of a bike. One thing I forgot to add here was the chainstay length. So this is the distance from the bottom bracket shell to the rear dropout. And what I'm trying to do here is really minimize it. I want to try to squeeze a lot of wheel into a really small chainstay length, and so I want to hit it at 400. Should be able to do it because it is a single pivot, and it's going to be a single pivot suspension. And so the swing arm is actually, it's not going to be your typical chainstay here. It'll actually have like kind of a swooping swing arm that'll run out from the pivot point. So that lower, a lot of times when you have your swing arm down low, there's a lot of stuff between the back of the tire and the bottom bracket shell. Here there won't be anything. So we could probably tuck it in there pretty good. So I'm hoping that 400 is going to work. I'm going to go back to the front of the bike now, and let me finish what I was doing. I'm going to draw a circle here, and this is going to be that radius of 400, which will be the chainstay length. I'm going to go back to the front of the bike. I'm going to draw a circle here that is equal to the diameter of the front wheel, and it's going to be 584 is the diameter. And so that's from here. Again, bead seat diameter is the technical term for it, and so all 27.5-inch wheels have a bead seat diameter of 584, and that's where the tire, the bead of the tire sits in that little groove, and that's the diameter of it. So I like using that as a reference point. And then the front wheel diameter, 725, and this is, I just measured this directly, and normally, oftentimes I'll offset this, and I'll show you how to do that in a second. But I'm going to just draw another circle, and it's going to have a diameter of 725. Right, so this is the front wheel and tire combo. And then you draw a line down here, put a point at the base, and then this here will be our ground point, so that this is where the rear tire is going to sit on as well. And because the rear tire is a 2.6 and the front's a 3, there's a slight difference in diameter, which will throw things off a little bit. The other way we can get to the tire diameter is if we just know the bead seat diameter here, and this is just an estimation technique. You can grab the calculator and take your tire diameter in inches, so 3, and then multiply that by 25.4 millimeters to the inch. So this will give your, that tire depth, roughly in millimeters. It's a little off, so I always multiply it by 0.9, and it seems to do a pretty good job. So 68.58 would be that offset. And we'll just call it 60. We'll call it 69. So if we offset this 69, you can get to the more or less the same thing. And if you look at the diameter of this, and you end up with 722. So awfully close. When you actually ride the bike, the tire is going to be compressed. It's going to be not compressed, depending how much weight you're putting on it. So these, as long as you're within a few millimeters, as long as you're within 5 millimeters on these tires, it's not a big deal. I'm just going to undo this and get back to my original tire here. And the next step is to figure out the where the rear tire is going to be. And so 715, I'm going to do 715 divided by 2. And so that's 357.5. Right? So I'm going to offset. You can actually do the math. Just done it in Rhino. So you can actually do the math in Rhino. I often do it. So 715 divided by 2. And if we offset this 715 divided by 2, the rear wheel, the center of it, is going to be at the intersection of that 400 millimeter chainstay length that we drew and the offset of the, the radius of that tire. So I'm going to put a point here, and then I'm going to draw the wheel and tire in, the circle, diameter 584 for the wheel, and then circle, diameter 715 for the tire. And I'll keep that baseline in. I'm going to delete this. I'm going to delete this. I'm going to delete this line. I'm going to delete this one too. And now I'll also delete that. Okay. Save this real quick. All right. So we've got the two wheels and tires. We know where our seat, the distance between the top and the bottom of the effective seat tube is going to be. This seat tube is going to have a curve in it, so it won't actually follow this. And then we have a pretty good idea where our head tube is going to be. So we're in good shape to start drawing the front triangle of the bike. And the first thing we want to do is figure out where this down tube is going to be. And the down tube needs to clear the fork. And so the fork has about 200 millimeters wide. So one side of it will be 100 millimeters, right? And that 200 millimeter width, it sits a little bit below the bottom of the lower headset cup, about 15 millimeters. So I'm going to drop this 15 millimeters here. I'm going to put a point here. Those are pretty conservative numbers. It's probably more like 190, and the drop is probably more like 17 or 19. So I like to be a little conservative so my fork isn't hitting my down tube. But in order to have some clearance here, we're going to draw a circle around here that will be 5 millimeters in diameter. Make it 5 millimeter radius. And we're going to offset this half the distance of the down tube. So we'll get to the center line of the down tube. So offset this. We're going to use an 1.5 inch down tube, so 38.1 divided by 2. Offset that there, right? And now we can draw a line from the center of the bottom bracket shell. And we're going to run that tangent. Run a line tangent. Sometimes the Rhino is funny this way. To start in certain orders. Whereas like AutoCAD, you can kind of do whatever. So I'm going to draw a line tangent to the circle, to the center line, or the center of the bottom bracket shell. And then I'm going to extend this to the head tube. Right, and so that's the center line of that down tube. I'm going to offset this 38.1 divided by 2. And so this will clear the fork. That little dot, that point, represents the corner where the fork is. So it'll clear it by at least 5 millimeters. The other thing we want to make sure, we want to see what the distance here is. 14 millimeters, which is fine. The Paragon Machine Works head tubes, they kind of look like little, I don't know, little silos, like little nuclear power plant silos. And so there's this little lip here that, actually, I'll get one just to show. Hold on one second. All right, so Paragon Machine Works head tube. You see this little lip here, and this is, I don't know, about 10 millimeters between the edge and kind of where this lip radius stops. So I always like to just double check to make sure that the distance that I have between the bottom of the down tube and the bottom of the head tube is more than 10 millimeters, so I'm not running into that lip or the curve that goes down to the lip. Okay, so we got our down tube in. Next, again, I'm just kind of cleaning up as I go here. The next thing I want to do is draw in the seat tube. And so for the seat tube, it's going to have a bend in it to clear the suspension travel and just allow more space for the wheel. And the beginning part is just going to be a vertical line up. And then there's going to be a bend, and then the seat tube will go generally this distance so that when the saddle is set at this height, it will be at exactly the right spot. To be at the 74.5 degree head or seat tube angle and that 730 millimeter distance. So the other thing we need to consider is the pivot point for the suspension. And for this one, rear wheel diameter, rear tire diameter, we worked on that. Rear travel is going to be 110 millimeters, and rear sag 33. We don't need to get into all this quite yet. Let me add one more thing here. What we want to do is figure out where we're going to put that pivot point. And I'll go into all this kind of decision making on another video, but where I want the pivot point is right at the top of or even like the center line of the chain, where the chain goes around the front sprocket. And there's reasons for that. For the single pivot, it gives a more kind of consistent type of suspension performance if you get that point right at the top of your chain ring. And so to figure out what this distance needs to be, we do a little bit of math in the calculator back up. So I'm going to run, of course it's going to depend on what size chain ring you run, right? And surprisingly, chain ring diameter has a lot of effect on how your suspension performs, which doesn't necessarily seem intuitive, right? So I like running a 34. I run a SRAM Eagle, a 1050 cassette. And I'm always like going back and forth between a 34 and a 36. I'm usually unable to push a 36 at the beginning of the season. By the middle of the season, I can usually do it. And so 34 works for me. I just, I like the 34. I'll just keep going with it. It's just simple. You might be running a 32, you might be running a 30. So just keep this in mind as you do this. And the other thing is you might decide to move that pivot point, up or down depending on what you want. You probably won't be moving it down because that kind of throws things off. But you might be moving it further up your seat tube by a couple millimeters. Anyway, like going off on a tangent here. All that to say is I'm going to use a 34 tooth front chain wheel. And so 34 teeth. Each one of those teeth are spaced ½ inch apart from each other. So that's 12.7 millimeters. Those are the two numbers you often need to remember. 12.7 or 25.4, and then half of that is 12.7. Two handy numbers when you're working in millimeters. So 34 teeth, 12.7 millimeters in between each one, gives you 431.8. That is the circumference of kind of the center line of where the chain sits. If you were to draw a circle through the pins of the chain around around that front chain wheel. So 431.8 is the circumference. If we divide that by 3.1415 pi, right? That will give us the diameter. So the diameter is 137.45, and then we divide that by 2, we get the radius. So 68.7. I'm going to call it 69. We could go 70 even. I'm just going to call it 69 though. So this distance between here and the center point, pivot point, is going to be 69 millimeters. So radius 69. 69. Okay, I'll put a point right here. All right. So this is the center point for our suspension swing arm. And so our suspension is going to swing from this point, and we know it's going to swing through that first sag point, right? And that suspension distance is vertical distance. And we lined it out as rear travel 110. So it's going to travel 110 millimeters from the bottom of the travel through that sag point to the top of the travel, right? And rear sag, we're going to set rear sag at 30%. Front sag, we set it at 20%. Rear sag is going to be at 30%. And so 30% of 110 millimeters of travel is 33 millimeters. So we'll offset this line down 33 millimeters. And we're going to put a point right here. And then we're going to take this line and offset it up. The full travel of 110. And we'll put a point there. All right. So we've got our travel for the rear wheel. So the rear wheel is going to, if there's no sag, it's going to, the center of it's going to be here. You sit on the bike under the right pressure, 30% sag, you get here. And then if you fully compress the suspension, you go all the way to here. What we want to make sure is that there's enough room for that rear wheel and tire when that suspension is fully compressed. So we're going to copy we just really need to get the rear tire from this point to the top point. And so this is where that rear tire is going to sit when the suspension is fully compressed. And we want to make sure that that tire is not hitting the seat tube. So I'm going to give myself 10 millimeters of offset here for clearance. And we want to get to the center line of the seat tube, just like we did before with the down tube. The seat tube is 1 3/8 in diameter, which is going to be 34.9 millimeters. So we're going to offset that curve 34.9. And then we're going to do the same thing we did before with the clearance for the fork. I'm going to draw a tangent line from here to this point here. I'm going to extend this down to that vertical line that I drew. Okay. I'm going to clean some of this stuff up. I'm going to take the pivot off. I'll leave these lines here that they can be helpful just to cite things. The next step is the bend of the tube that we're going to use. And so I've got one of the Cobra Frameworks tube benders, and the block that I have for the tube bender is a 230 millimeter radius bend. And so I'm going to use the fillet command, and then we're going to rate the radius as a 230. And so this is what our seat tube is going to look like. And if I delete the center line, and if I delete the offset line too, and then offset this line, again 34.9 divided by 2, here, 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 and here. And I'll delete, this is the initial seat tube line. And you can see that when the suspension is fully compressed, that there's clearance here between the tire and the seat tube, which is what we wanted. Okay. Leave those as well. And then I can even clean some of this stuff up. So I'm going to trim this. And the seat tube will sit behind the down tube in a notch when we're actually assembling the frame. Okay, well, the next step is to figure out where that top tube is going to sit. And so what we want to do is figure out what our standover height is going to be. And so for standover, I'm going to use, my inseam's like 31. And so I'm going to use 28 inch inseam, or standover height. And so 28 times 25.4. Let's see what this number is. It'll be 711. It's good. I'm actually going to make it 710 just to keep it easy. And so I'm going to offset this line, 710. All right. And 710, I just draw it through the bottom bracket shell. I mean, you can say it's a little bit in front of there. 50 millimeters or something like that. These are just numbers that, I fudge a little bit typically. And so this will be fine. I end up having a little less clearance is on this bike and other bikes than you might have on on your typical full suspension mountain bike, and that's because I want to put a bigger bag inside the bike for bike packing, and so I really want to maximize that in frame space. And so if I wasn't trying to put a bag in there, I might do it at 26 millimeter inseam or 26 inch inseam, or even a 25. Something along those lines. But because I'm trying to put a bigger bag in there, I'd like to get, something that, I'm not, destroying myself on every time I try to get on and off the bike, but also something that is giving me plenty of space for a bag. I'm going to offset the top of the head tube, 15 millimeters. To locate the top of the top tube. And the top tube will run through that standover point and to the C tube. Now, if we're using a straight top tube, this is all that we do, and this is going to be a 1.25 inch top tube, so it's 31.8 millimeters. And we just call it good, right? Exactly 90 degrees. So I'm going to put another point here. So, we draw that top tube, we'll be good to go. But I'm going to end up using a bent top tube just because it'll look cool and just have a slight bend. And so I need to find the center line of the top tube. So I'm going to offset this again, 31.8 divided by 2 to find that center line. And I am going to draw a point here. And a point here for reference. The next thing I want to do, I'm just going to rotate this. I want to find a line that goes through this midpoint of this top tube and is perpendicular to it. And then I'm going to rotate this line by 5 degrees. And then I'm going to draw a line from the intersection here to this point. And that represents the center of the tube that I'm going to run. Something got funky there. Okay. So this is the center line of the tube I'm going to run. And just like our seat tube, the bending die I have for 1.25" tubes, 31.8 millimeter tubes are 230 radius. So we're going to do a fillet, 230, and then we're going to offset this 31.8 divided by 2. And you can see this is actually a little bit over that, point, that standover point. So still, again, I'm not worried about this, but something to consider as you draw your bike where you want your standover to be. All right, so that are all the tubes for the front triangle. The next thing we want to do is just finish off this C tube here. We're going to run perpendicular here. And I'm going to offset this 30 millimeters up. I usually run 25 or 30, an inch or a little bit more than an inch. The top, and then I do want to make sure that there's plenty of room for a dropper post. And so, yeah, 320 is plenty. I think the RockShox 150, it's about 290 millimeters from the top of the saddle to the base of the collar. And again, I'm going to run this kid seat on here. So, I want to make sure that there's enough room for it. Cool. So that's the front triangle.